All right, we're moving on to talk about virtual networks. Now, virtual networks I view as the glue that tie various infrastructure as a services together. And we've seen so far in this course that virtual machines absolutely require a virtual network in order to have connectivity to the internet, to have connectivity to each other and to other Azure services. And you have the option within things like app services to connect to a virtual network to allow some control over routing and security and things like that. So in this video, we're going to create a virtual network, and we're not going to like when we create a virtual machine, it allows us to create a virtual network at the same time. We're actually going to intentionally create a virtual network from scratch. So you can go into the marketplace and search for virtual networks or VNet, and you'll get to something like this where you can say create a virtual network. Now, like anything, we have our wizard view of creating this virtual network. I'm going to create a new resource group to put this in, and we're going to have to give it a name. Now, the region of the virtual network does matter because you're going to be restricted to the virtual machines being from that region to add it to the same virtual network. There is a relationship between the location of the network and the location of the computing resources. So I'm going to choose West Europe to put this network. That restricts me from only putting VMs from West Europe onto this network. Then I'm going to click Next. Now, they've moved this around a little bit. The next tab is Security. So there are a number of services that you can add to your network, and these are paid services. So if you want to have Azure Bastion, we saw that earlier in the course for RDP SSH connectivity to virtual machines without having to open the ports. And we have an Azure Firewall option. We haven't talked about firewall yet. DDoS protection. And if you were to check any of these services, then you would have to, you're basically provisioning that service. So by checking Azure Bastion, it's going to ask me for the host name, and it's going to create a new public IP address for Bastion. Similarly, for firewall, we then start up the various firewall options. We're not going to do that. But there's an interesting side effect I'll show you in a second from me selecting these and then unselecting it. When we go on to looking at IP addresses, this is quite important, right? So the IP address range of a virtual network can be changed after you start with a number of private IP addresses that are available for use. And then you can, again, add to it if you need more. This space here, this 10.0.0.0/16, that's called CIDR notation, CIDR. And it's a bitmap, basically, a mask that will allow you to determine how many IP addresses are in this range. And we can see a clue underneath where it says 10.0.0.0 to 10.0.255.255. So this /16 basically is a mask over the first two octets, and then the other two octets of this are the full range. If I said /24, then you would only have 256 addresses available. And if I said /8, I would have the full 3 final octets available. You don't need to make this too big, like 65,000 addresses means 65,000 virtual machines, which is quite a lot. By default, you get a subnet called default. Notice the subnet is smaller than the total addressable space for the VNet. So by default, I'm giving it /24, which is, like I said, the 256 addresses. That leaves tens of thousands of other addresses that I could allocate with other subnets. Because I selected Bastion and Firewall on the previous screen and then unselected them, Azure is helpfully allowing me to create 2 additional subnets for those. And as you can see, it is 2.0.1 to 63 and 2.0.2 to 63. So we're actually wasting 3/4 of this part, this D block, I guess. So we can see here it's done some helpful things for us. Now, typically what you do with subnet is you want to divide your network across security zones. So you might have a subnet for front-end websites, a subnet for databases, a subnet for middle-tier applications, etc. So each subnet can be secured differently using a network security group. If we wanted to change this, we could add an address space. If we wanted to add additional subnets, like we have the middle tier and the back end, we can add a subnet. I'm not going to do that right now. We'll add the subnet later in this course. So I'm going to set the defaults, including the Bastion and Firewall subnets, not including those services. We'll skip over the tags, and we'll get to the validation element. Now, virtual networks are free. There's no charge to create them at this moment, but you are limited in the number of virtual networks that can be associated with your subscription. I think it's 250 virtual networks per region. So don't go absolutely crazy with creating them, but you can create many, many of them and not worry about racking up any charges until you create resources like a virtual machine attached to it. So I'm going to click the Create button. We'll let that run. Now, this took only a couple of seconds, and I think the reason is because there's not actually resources being instantiated when you create a virtual network. You're really just, it's really entries in a database table. Microsoft has hardware, wires, hubs, and things, and all they're doing is just learning how to route traffic for you, and those are just entries in a database behind the scenes. I can say go to resource, and now we have a virtual network. As we saw, we have this one address space, a rather large address space, but the 10.0.0.0 address space. This is not accessible from the public internet. It's a private address. And in terms of subnets, we've got the 3 subnets, one default and one for Bastion, one for firewall. And we don't have any devices. We haven't deployed any VMs to the existing virtual network subnets, okay? So that's how easy it is to create a virtual network. In the rest of this section, we're going to talk about the various requirements for the exam, the various issues in terms of setting your virtual network. So as you can see, we don't have any devices on our VNet. So maybe before we go any further, let's deploy a little virtual machine to this. So I'm going to create a Windows Server 2019 data center virtual machine. Just for convenience, I'm going to put it into the same resource group. I'm going to call this a VM demo. No infrastructure availability. Just leave it as a standard VM. This one is very small, B1S. I'm going to upgrade that to B2MS. And put a user ID and password. Just for demonstration purposes, I'm not going to open any ports, okay? So let's assume that there's no ports open at this moment. We'll skip over the disk options and we'll get into the networking options. Now you can see it's chosen my VNet by default because I have one in that region. If I chosen a different region, it wouldn't be available to me. It's putting this virtual machine into the default subnet. But in this particular case, it's coming up with a brand new public IP. I'm going to say no to that, okay? We'll let it create a network security group. We're not going to open any ports. So right now, this machine will have an internal private IP address that starts with a 10 and will not have a public IP address. I'm going to skip over most of the next settings here. No diagnostics. Skip the advanced and get right into review and create. 10 cents an hour for this B2MS. Click create. So I'm expecting is that it will deploy this B2MS machine onto this VNet, and we'll see that in a second. All right, so that was pretty quick. We can say go to resource. Machine is still starting up, obviously. Go into the networking settings for the virtual machine. And we can see the network has a network interface card, and the network interface card is attached to our VNet. Let's get out of here, go back into our VNet demo, and go into connected devices. And now we can see the network interface card is connected to our VNet using the following IP address. So it's an internal IP address on the default subnet. So this is exactly what we were expecting. And so in this way, we can create devices, deploy them into the various subnets that we create. These Bastion and Firewall subnets are obviously reserved for those Azure services. And in this section, we will talk about setting up the security, opening up ports and restricting, let's say we have a front end and a back end subnet. We'll talk about how to basically protect those by closing off ports. Now, just to further demonstrate this, I'm going to create a couple of additional subnets onto this virtual network. Now we can see that 10.0.0.0 is already taken the full /24 range. 10.0.1.0 is only partly taken, about a quarter of the range, and the same for 10.0.2.0. So I'm going to create a, let's call it mid-tier subnet, and you'll see it's automatically offering me up 10.0.3. So these cannot overlap, and they must be sub-ranges of the total address space for the entire virtual network. We have the option of getting IPv6. All of Azure now supports IPv6 connectivity, and we can select any sort of gateways, any security groups, routing. We won't do that at this time, but we have a lot of advanced options. Now that's as easy as it is to create a subnet. We can call it back tier, and we get the 10.0.4 range and stay safe. So now I have 3 subnets that are from my creation. Now, one thing that's kind of bothering me about the inefficiency here is that we do have, I said, a subnet that is only using 59 or 64 effectively IP addresses out of a 256 address range and wasting the others. So what I'm going to do is I want to edit this firewall subnet so that it is running beside this Bastion subnet, and we're not wasting potentially a space of range. Now, the reality is you don't have to be so thrifty with IP addresses in the private space because there are millions of them, and you probably will never run out of private IP addresses. But maybe there's a little bit of wanting to be organized here. And so I can change my subnet range for the firewall. You'll see that this one, each of them have 64 addresses that they're asking for. So if I change this to 10.0.1.64/26, I'm actually reserving the next block of 64 next to the Bastion subnet, and I'm freeing up this 10.0.2 for another purpose. So I can even edit the range of a subnet as long as there's not other things running on it, okay, to be clear. So if there is devices running on this subnet, then I can't just decide I want to change this to a different, let's put this in a new subnet range, because my network interface card and other things have IP addresses in the old range. So be careful when you're renaming subnets that what's the downstream implications for devices that are running on it. So I won't touch the default, but we can leave the this as this, and you can see you're not restricted to this .0 ending. You can actually stack them quite nicely here. So right now, we have a virtual network with some subnets, with a virtual machine that has a network interface card connected to that subnet. Right now, everything is set to private. There is no public IP address for this network interface card. What we're going to do in this video is we're going to create a public IP address and associate it with this network interface card. And basically, we can then start to open up some ports and get some traffic. Now, we could have done this all during the creation screen, but I think there's value here in doing this step by step to see how it works. So let's create a public IP address. So I'm going to search for public IP address. Now, public IP addresses are not free. So as of March 2025, Microsoft has deprecated the basic IP address tier. That is no longer available. That means they're also deprecating dynamic IP addresses, which are not available as well. Your only option is to create a standard IP address, which gives you a static IP address at ½ cent per hour. So if you want that option, that's the price for that. All right, so let's go into the thing here. We're going to create a public IP address and say create. I'm going to put this into my VNet demo resource group. Now we can choose a region for that address. I'll keep this in West Europe. We give it a name, so usually it's like PIP something or other. We can choose whether we want a v4 address or one of those new fancy v6 addresses. Now, a reminder that the basic tier no longer exists. So standard is your only option because the standard load balancer is the only option. They don't have a basic load balancer anymore either. So all of these options should match your load balancer. When you choose the standard option, which is the only option, you get the choice of availability. Either it is not zone redundant at all, or it is zone redundant, or you can deploy to specific zones. Again, this should match your load balancer. Also with the tier, we saw on the pricing that there's global pricing versus regional pricing. Again, this must match the load balancer. So we'll leave the regional pricing by default. And you'll see we don't get the choice of dynamic versus static at the standard tier. Now, what we're going to want to do is we're going to want to give this DNS a label. So I'm going to say AZSJDVM as my label, and it's going to be fully qualified here based on the region you chose. And this is a preview feature we won't talk about. Now, another new thing in this is DDoS protection. Now, you know that DDoS protection is now available in terms of either the network tier or versus specific IP addresses. So if we want DDoS protection for this IP address, we can sign up for that. There's a cost to that. Or if we want hundreds of IPs to be covered at the network level, we can sign up for network level DDoS protection. Or we can say we're not going to have any additional DDoS protection, which I'm going to choose disable in this case. So I'm going to skip over creating tags, and I'm going to let it do its review here and say create. Now it does create fairly quickly in terms of the resource itself. I can say go to resource. And you can see I've been assigned a public IP address. Again, this is a standard SKU, it's a static address. Even if I'm not using it, it will be, this address is reserved for me. There's a cost to it. We saw earlier it's ½ cent per hour just to hold it. When I'm ready to associate this with a network interface card, I can associate here, or I can go into the network interface card itself and associate it as well. So this is a public IP address now that I can use for various resources that need to be accessed from the public. So now we have this dynamic IP address that is yet to be assigned, and all we can do is associate it with the network interface card that will give the virtual machine a public IP address. So I click on the associate button within the public IP address. I choose network interface, and I can choose the network interface card right here from the drop-down list. Alternately, I can go into the network interface and I can add an IP address from within there. So there's two ways to go about this. So I'm going to click OK. All right, so we successfully updated that. Now, what I'm expecting if I refresh this, I guess I could give it a moment to come up with it. We're going to go into the virtual machine here under networking. We can already see, that there's a public IP address that's associated with this network interface card. And it takes me back to this one that we just created. It now has a public address. Now, if I go to the network interface card itself, under IP configurations, we can see that the same basically network interface card has both a private address and a public address. So virtual machines on the same network can refer to this machine using its private address, and of course publicly can be associated with this address. Now keep in mind that the security is still enabled, and there should be really nothing that we can do if we try to ping this address or we try to remote desktop into it. Certainly we haven't installed a web server yet, so there's nothing listening on port 80 or 443. The network security group should have really shut this down and not allowed any traffic to it. So there's public IP address. Hopefully there's really very little that can be exposed to the machine. Now we have a whole section talking about securing access to networks, network security groups, effective security rules, and stuff like that. But just briefly, I will show you. We go into network security group, and it shows us here. Actually, we are going to have to go back up to the resource group, and we'll see network security group as something that exists. And if we look at the inbound security rules, basically we have a deny rule on all inbound traffic. The only traffic allowed is from the same virtual network or from a load balancer. So there should be no traffic allowed to this public IP address and to the server at this time. So we saw in the last video that this network security group is attached to the network interface card that's attached to our virtual machine. And right now it does not allow any traffic in from the internet. Since we've assigned a public IP address to it, let's start by attaching or allowing RDP traffic to go to that virtual network. So I'm in the network security group under inbound security rules, and I'm going to say add. We're going to allow traffic from any source, so we could put our client IP address in here if we wanted to. And we are going to choose, for a shortcut, we can choose the RDP service, and it tells you port 3389 for TCP, and we allow the rule. Now priority, the lower number has the higher priority. We have to give it a name. We should give it a name that is, let's say, relevant to this. So allow RDP and say add. So now it's going to take a couple minutes to go into effect, but now the network security group is going to allow traffic from outside over this port onto the network. Now, after a couple minutes of allowing this to sort of filter through, we can go right to the virtual machine, and like we did earlier in this course, go to the connect menu item under RDP. It will check to see if we have access, which we should, now that we have the rule created for the network security group. And here we go. We have the RDP file at our disposal, and we should be able to establish a connection, which we have, right? So that's how I would say straightforward it is to create a public IP address associated with the network card, open up the rule, and then be able to connect to this virtual machine using the remote desktop protocol. Of course, you shouldn't have ports open on your network security group if you don't need them. And so this type of RDP port should be either very limited, you should use a Bastion server, or you should remove all of those types of open ports for security reasons. Now, when you're setting up a complex production environment with multiple networks, multiple servers, multiple applications, sometimes you do need to have them communicating with each other. And by default, any server that's running on a virtual network, let's say in this case, NewTest1, will not be able to communicate with a server running in a different virtual network, call it NewTest2. So there is a boundary, a network secure boundary between these two different virtual networks. And if you set up network security groups and you have different subnets on your network, you even have boundaries of security groups between the different subnets. So in this video, we're going to talk about a concept where we're going to be connecting two different virtual networks called peering. Now, peering is the idea of setting up a relationship between two virtual networks such that they recognize each other. And this allows virtual machines running on one virtual network to communicate with virtual machines running on another virtual network because they recognize the IP addresses in their network space. Now, an important prerequisite for this is that each of the virtual networks that we're going to be setting up in a peering relationship have to have different address spaces. So we can see that NewTest1 has the 10.3.0.0 address space, and NewTest2, in this example, is 10.0. And so they do not overlap in terms of addresses, and so we can connect them. So we're going to go into NuTest 1 in this example and scroll under Settings, and there's a menu item called Peerings. And so we can see that right now there's no peerings. NuTest 1 is an isolated virtual network. There's no connectivity to any other virtual network. And we can say Add. Now, it's possible to have multiple peerings between a virtual network and other virtual networks. It says 2 or more. And you can set this up. There's even a model called the hub and spoke model, where you have one virtual network as the center and other virtual networks as the spokes, and they can communicate with each other, things like that. So you would do this using a peering relationship if you were trying to set up a hub and spoke model. But in this case, we just have the two, and we're going to just connect them A to B. So we do have to give it a name. And so I can say VNet2 to VNet1, because this is under the remote virtual network. And we're setting this up for VNet2. We are authorizing traffic to travel from the remote network, which is 2, to the local one. And we have the other link, which is from the local to the remote. So this is, in fact, VNet1 to VNet2. So you see what we're doing is we're setting up two connections on one screen. This is to go from the remote to the local, and down here is from the local to the remote. And we are authorizing the other traffic. So we could obviously make this a one-way connection, but we're going to let this be a two-way connection. Now, there are other options here for forwarded traffic. So let's say the traffic is not originating from NuTest 2. Let's say there's a NuTest 3 that is forwarding traffic through to. Do we want to receive traffic that has been forwarded? There is the gateway inside of NuTest 1. If we were to create a gateway, do we want to allow it to forward the traffic on? And do we allow NuTest 2 to use the gateway on NuTest 1? We're going to be talking about VPN gateways a couple of videos from now. But this is basically, if we're going to set up that hub and spoke model, or we're going to use a single VPN gateway to do site-to-site VPN from a corporate network to Azure, but we want to allow other networks within Azure to use that same site-to-site VPN, we would have to enable some of these things. So I'm just going to say add. We've got a very simple two-way connection between VNet1 and VNet2, and I'm just going to say add. So right now we've got two deployments going on. So they're deploying both of these as things. So we'll see under peerings for VNet, for NuTest 2, that peering did get connected. We're in a connected state, and they're really up to date. If we go over to NuTest 2, which is what we were calling the remote network, and go under peerings, then we'll see that the second connection, 2 to 1, has also been set up. So what we've done is we've created two peering connections, one from VNet 1 to 2 and one from VNet 2 to 1. And now any device on either of these virtual networks can see and communicate with any other device on the other network. And so this is a peering relationship. Now, these connections still have to follow network security group rules if you have an NSG involved. So if you have servers on a subnet and it has NSG controlling that subnet, the traffic still has to obey the rules for ports and destinations and sources. So peering doesn't override your security settings, but it does allow it as a bridge to those connected networks to talk to each other as long as they follow NSG or firewall or other settings that you have protecting traffic on that network. So in the last video, we set up virtual network peering between two networks in the same region. This is West US 2. And I should point out, I should have said it in the last video, but I'll say it here, that there is a cost to that. Okay, so VNet peering within the same region has a cost for the inbound data transfer and for the outbound data transfer. So what that means is if you're sending a single gigabyte from VNet or NuTest 1 to NuTest 2, you're paying a cent per gigabyte for it leaving, and you're paying an additional cent per gigabyte for it arriving. Okay, it's 2 cents per gigabyte to send 1 gigabyte between two networks on a peer. Now, this could add up pretty quickly. If you're talking about 100 gigabytes per hour, then that's $1 per hour of data charges. Okay, so that obviously can add up pretty quickly. But what about if the virtual network is not in the same region? So let's talk about connecting NuTest 1, which is in West US 2, to NuTest 3, which is in Japan. This is called global peering. So I'm going to go into NuTest 1, into peerings. We still have our connection to NuTest 2, but I'm going to add VNet 3 to VNet 1, and we're going to choose this Japanese VNet as the remote network. And we're going to allow that data transfer, and then we're going to do VNet 1 to VNet 3 as being the local name, and we're going to allow that access. So what I've effectively done is I've set up global peering. There's a whole different set of charges for global peering. So you're basically paying for the data to travel halfway around the world. So you'll see that Microsoft has broken the data into zones, 1, 2, and 3. And the zones is basically the different regions of the world have been set up into these zones. let's look at the different zones here. All right, so zone 1, West US 2 is in zone 1. This is it's in Australia, Canada, Europe, UK, things like that. Zone 2 is got some specialized Australian East and Southeast zone, India, Asia, Korea, and Japan is in zone 2. And zone 3, most expensive zone, is Brazil, South Africa, and UAE, okay? So what we have is, if we're sending a gigabyte from West US 2 to Japan, we have 3.5 cents per gigabyte leaving, and we have 9 cents per gigabyte arriving. So that is 12.5 cents per gigabyte for data to go between the two global zones in this particular example. Okay, so this VNet 1 to VNet 3 has gone from 2 cents a gigabyte for local traffic to 12.5 cents, so effectively 6 times the cost to set up global peering. But that is just the reality of paying for bandwidth traveling over Microsoft network between two regions. So make sure you're sending only essential data and that you're not just being overly verbose for no reason. And that is VNet global peering. Now, virtual network peering is only one way that we have to allow traffic to travel between two virtual networks. Another way we can do that is using virtual network gateways. Now, you might know that a virtual network gateway is also the device we use when we want to set up a VPN. And so sometimes it's called a VPN gateway, either a site-to-site VPN or a point-to-site VPN. Just to remind you, a site-to-site VPN allows you to connect, say, your corporate network into the Azure network so that you can communicate them together. And so you have a virtual network gateway on the Azure side and an actual physical network gateway on the corporate side. You connect these two devices together, and then you would have encrypted communication between them. But what we're talking about in this scenario, it would be more in tune of VNet to VNet communication. So you can do the same thing that you do between your corporate site and Azure between two virtual networks using virtual network gateway devices on both sides. So let's do this as an example. So I'm looking at my virtual networks in the Azure portal, and I want to pay attention to two of them. One called NewTest 2, which is located in West US 2, and one called NewTest 3, which is located in Japan. Now, if I had a device on NewTest 2, it could not communicate with a device on NewTest 3 unless I set up global peering. The other way we can do this is through virtual network gateways, and this is what we're doing here. So I'm going to go into NewTest 2, and I'm going to look under settings and under subnets. Now, I will point out that I have a default subnet that is a /24 size, but the whole network itself is /16. So there's plenty of address space for additional subnets. Obviously, if in your example, the size of the subnet is the same size as the address space, then you're going to have to create more address space. But in my case, I do have room. So the first thing we need to do is create a gateway subnet. So I'm under subnets, and I'm going to press the plus subnet. And we're going to create a subnet for our virtual network gateway. So under subnet purpose, I'm going to choose virtual network gateway. These subnet gateways have a name of gateway subnet. So it's chosen the next available starting address with the appropriate size, and then I can say add. All right, so this is the location. The gateway subnet is where we have to deploy a virtual network gateway. So I'm going to go back to the home screen, say create a resource. So we're looking for virtual network gateway. And so we'll create a virtual network gateway. So we're going to call this VNet 2 because it's going to live in testnet 2. We'll deploy this first one into the West US 2, which is where the network is. We're using a VPN type gateway. Now we have a number of SKUs to choose from GW1 up to GW5. We can flip over to the Azure documentation for VPN gateways, and we can see for VNet to VNet tunnels, it's ignoring generation 1 and going down to generation 2. There are limits on the number of tunnels that we can create. So GW2 and GW3 are limited to 30, and GW4 can support up to 100. So obviously we don't need a big tunnel just for this demonstration purposes. We can pick the GW2 offer. So I'm going to put this on NewTest 2, which is the one that we're dealing with, the gateway subnet automatically selected. And because we're doing these virtual networks this way, we do have to create an IP address for it. So this is going to be, VNet GW2. We'll leave the default. We also should create a secondary public IP address, and I can call this second. So we're going to leave all of the defaults here for this internal VNet to VNet communication. Review and create. Now we're going to leave that. We're going to go back to our virtual networks and to our other network is in Japan East. And one thing I didn't do was create the gateway subnet for that. So I'm going to go and just create a virtual network gateway. and say add. Then we go back to virtual network gateways, not ExpressRoute, but VPN gateways, and we'll create VNet 3, which is going to be in the Japan region because it has to be in the same region. Remember, we're doing VPN types. We'll leave the GW2 SKU. Now we can choose our Japan network from there. And we'll give it an IP address and name. We also call the secondary address and name. Leave all the rest, the defaults, and say review and create. And so that'll create the second gateway subnet in the Japan region. All right, so that took about 22 minutes. The other one took about 25 minutes. So now we have two VNet gateways running on two different VNets. So if we go into virtual network gateways under VPN gateways, we can see we have two of them running in the two regions. And when we come back, we're going to connect these two virtual networks through their VNet gateways. All right, so in the last video, we created two virtual network gateways, one in West US 2 and one in Japan. Now, before I connect them, I'm going to have to make a little bit of a change. Right now, both VNet gateways have the same ASN. And so connecting them using BGP is going to fail because they have the same ASN. So I'm going to change the ASN for the Japan VPN gateway. So I will go into configuration, change that number, and say save. So in this update, we're going to be able to use BGP to connect them. So I'm looking at the gateways I've created. And what we're going to do is we're going to create a connection from VNet 2 to VPN 3 gateway. And then we'll create a connection from VPN 3 to VNet 2. So I go into the virtual network gateway and I go under connections. Right now there are no connections. And I'm going to say add. Now we have a bit of a challenge in that the connection has to live in the same region as the VNet. So I'm going to create this in my resource group. I'm going to create a VNet to VNet connection. Now we do have this option for bidirectional connectivity. But again, the problem is if you're trying to create two connections at the same time, both of them are going to be created in the same region. And our challenge here is that they have to be created in two different regions. So I'm going to create the West US 1 first, West US 2, and I'm going to call this VNet 2 to VNet 3. That's the name of the connection. And so this is a one-way connection from West US 2 to Japan. And so I'm going to pick the West US as the first, and I'm going to pick the Japan as the connection. Now, we have a couple of different authentication methods. One of them is called the pre-shared key, PSK, and that's just like a password. And so I'm going to hard code a password in here. I could create a certificate in a key vault, and that's a more complicated way of authentication, of course. Now, I'm going to leave the defaults, except we did change that ASN number in order to be able to use Border Gateway Protocol. The big advantage of BGP is that it allows for automated sharing of the resources in each network to the other. And instead of having to manually set up routes to say that if somebody wants to reach something in the Japan network, then you have to create a routing table. This is going to be automatic. Now it is telling me that I need a standard SKU, but I believe I do have a standard SKU, so that's not really an issue. I'm going to leave everything else as the defaults, and I'm going to say review and create, and then say create. Now I'm going to let the deployment for this run, and while it is running, I'm going to go to the Japan VPN and go under connections, and I'm going to say add. Again, this is the ability for devices running in the Japanese network to find and connect to devices in the West US 2. Again, it's a VNet to VNet. I have to give this a name. I'll call this VNet 3 to VNet 2, and this is where I choose the Japanese network connecting to the American network. Give it a password, enable BGP, and say review and create. Let it validate, and say create. Now, if the two VNets were running in the same region, we could do the bidirectional connection, but again, the connections have to be made in the same region as the source network. We'll let that run too. So if I go into VNet 2, which is the last one we were working with, and under connections, and I say refresh, now I can see that the VNet 2 to 3 is starting up. It's in an unknown state, and VNet 3 to 2 is still being created. So that's in an updating state. We do need to wait until this is successfully connected. And while that's running, let's talk about why. Like, we have a couple of options here. One of them is peering. Now, peering is being charged per gigabyte. And so as data is being passed from West US 2 to Japan, it is being charged for that connectivity twice. So the leaving of the US is being charged at one rate and the entering into Japan is being charged at a different rate. So effectively you're paying double the connectivity, the traffic charges, one for leaving and one for entering. With a VPN connection, you're paying a monthly charge for the VPN, so you're renting this virtual device, and you're only paying for the egress charge, not for the ingress charge. So it's effectively 1/2 of the bandwidth rate for this VPN connection, but you are paying a fixed monthly rate for the device. If you already own the devices, let's say you have site-to-site VPNs or ExpressRoute VPNs set up, then you're not paying anything extra for this VNet to VNet connectivity, and you're saving half of the cost. So it's depending on the volume of traffic between these two regions. It could be more cost effective to set up a VNet to VNet tunnel using VPN gateways, and especially if you already have the devices running for other purposes. So you'll see VNet 3 to VNet 2 is now set to connected, and we're still waiting on the second connection to be established. And actually, the last thing I'll mention about the advantages of this is you can use VNet to VNet tunnels connections across different subscriptions. Now, you can't use it using the portal. Like we saw, it filled it in by a drop down, but you can set up this connection if you know the fully qualified resource ID, and you can do that using deployment scripts or command line utilities. So that's an option too. You aren't restricted to your own subscription for setting up these connections between VNets. So this is the end of the section talking about VPNs and VNet to VNet connections as well as peering.